right, welcome everybody. Welcome back in Hall 6 here. I hope you all had a good cup of coffee or two. I think looking at your faces, you definitely look fresher than before. Our next speaker, he's actually coming here all the way from Marseille. And as you might recognize, he's also one of our co-organizers. This is due to the fact that, as I mentioned in the keynote or before the keynote, we actually had to drop in some people because many speakers actually quit on us. Exactly 13 speakers quit on us out of 32, which is more than a third. So that's why we had Henrik as a drop-in, but he's a really, really, really good speaker. He's a podcast host. Anybody know, is it observable? Yes, some hands over there. The other guys, definitely check it out. He's an avid YouTube producer. He has really high quality content. He also did content on his next talk. This talk is actually going to be focused on Kubernetes security and which tool to trust with. Henrik is a senior staff engineer at Dynatrace. I think that's pretty much the best you can get. Correct me if I'm wrong.
I don't know.
Sky's the limit. Please give him a hand and enjoy the next 45 minutes.
Thanks for the intro. All right, so I hope you like security. Who likes security here in the hands? I don't see. A couple of hands here. How many of you are doing any runtime security? Do you know any runtime agent? A couple of hands. Okay. All right, so today we are going into an adventure together. So if you're up to that, I need your help because I don't like to present 45-minute slides. It's kind of boring, so I need your support. So are you ready to follow this adventure? Oh, that's a small yeah. So, because we'll take a 5 minutes break, grab some more coffee and come back, and then I will re-ask the question, all right? So are you ready for the adventure? A bit better. All right, so it's going to be, if you recognize, an Avenger theme. So we're going to have a couple of security superheroes, and we're going to figure out which one is the actual Avenger. So that's the purpose of this talk. Before I start this presentation, let me just do a few more words about myself, even if you did a great job. So I am a CNCF ambassador. It's for now a year and a half now. And also, I spent all my career as a performance engineer. So meaning testing, breaking, tuning. I think the performance engineering practice is a fantastic practice to learn architecture, because you discover different architecture patterns, you know how to tweak them, to tune them. I think it's the best way of becoming an architect for the future. So for those who never did any performance engineering and you want to discover new technologies and new stuff, go ahead. It's the perfect practice for that. So I'm still, in fact, part of a podcast team called PerfBytes. That's why performance is still in my heart. And you will see that the way I'm designing that talk is about performance. So I still have it's more raw, but I still produced a couple of months ago content on PerfBytes, which is a YouTube channel. It used to be a podcast, now we are a YouTube channel that talks about only performance stuff, performance methodology and stuff like this. And like mentioned, I have Is It Observable, which is a YouTube channel dedicated to observability, of course. And I also introduced a couple of topics about Kubernetes, security, basically everything that I'm working on. I'm trying to make a video out of that. All right, so before we start this adventure, I need a disclaimer. So the first one is I did a lot of tests because at the end it's a benchmark. So I can guarantee for sure that none of the Spartans, the Eagles, the Shields, any of them were destroyed. They did a good job in terms of load. So this talk is not to blame any of those projects. This talk is more about helping you to figure out which project should I pick for my projects, depending on my needs. And again, the idea is that this talk also has been built, this is the second version, because I did a first version with Tracy, which is not a CNCF project, and this one I replaced with the official CNCF project. So I will present those toolings. When I did the benchmark, those products has evolved slightly, so maybe things that I'm going to mention today has changed. Maybe. I don't know. We can figure out on the next version of that talk. All right, so let me introduce the superheroes, starting with the oldest one on the game, which is Falcon. So Falcon comes from the sysdig gang. It's been out there since many years. Did a pretty good job for us, and a lot of people has been using Falco in many Kubernetes clusters. And yeah, the question will be, is it still relevant? We're going to answer that question. Then on the H perspective, the second one will be the B, so Tetragon, from ISO Violence, so Cisco team, so behind the Cilium project. They pitch a lot of eBPF, but you will see that eBPF is in all of those products. Then we have KubeArmor on the shield, the Spartan, which is a really interesting way of doing things. I think it brings a lot of great ideas. So the question will be, is that really helpful for us? And then we have Kubescape, which is the new player from the CNCF perspective. They were focused on specific areas. So I placed Kubescape in this benchmark, but you will see that Kubescape is not only doing runtime security. And it's not only an agent. He's doing more than that. So when you will present the results, consider the fact that it's just not a runtime agent. It does all the security spectrum that you expect from a security tooling. All right, so for this, what are going to stay? If you stay with me, I hope that you're going to stay with me, we're going to cover a few things. So first, we're going to explain what we actually expect from security agents. Because having an agent is great, but actually there are a couple of core features that we expect from those stuff. Then, to be able to compare those solutions, we're going to go through different stage, design, what are the components that are required, so the architecture of those solutions, security behavior. I won't cover it much, to be honest, but we will do it behind the slides. And then we have observability, of course. And last is looking at what are the latency that those security agents is added to our applications. Technically, we say, no, it doesn't add anything. But stay tuned. We'll see if it's actually add more things. And last, I will share a conclusion with what are my recommendations, the scoring, to figure out which solution makes sense for you. All right, are you ready? Gosh, it's boring. I am boring or no? Okay. All right, so let's start with the powers. What are the powers that those superheroes need in their hands? We're going to cover that. So we need a couple of things. We need to be able, as any camera or that you have in the airport or anything, you need to be able to capture, to record things. That's the first element that is required. And then, of course, a camera requires some hardware or some electricity. So we need components to run this, to be able to capture things. And then, of course, by nature, those solutions will expose observability, because security, I think, from my perspective, is another pillar for observability. So we will see what are the type of data they will expose to us. Of course, the performance. It's great to have something capturing, but if everything freezes, doesn't make sense. And last, security. How do they react on suspicious problems? Are they just capturing things, or are they actually reacting to things? So we'll try to cover all those aspects one by one. And in this presentation, I will have some different slides, and I need you to tell the title and not me, all right? So stage one. Components! Oh, gosh, okay. Oh, it's hard, it's hard. All right, so every security agent, as you can understand, the idea is that a hacker will take control on our container, even if we do the best things to avoid that. And once they're going to hack our system, they are trying to play with touch files, launch processes to scan the network, to do suspicious things to be able to take control in the cluster. And the best technology on putting things to be able to detect anything, it's going to be eBPF. So how many of you know eBPF here? Ah, it's good. It's the first time. So for those who never heard about it, it's just, to compare it, it's a bit like a JavaScript for kernel. So you know JavaScript, you change some UI, and then boom, you have an event, and then some JavaScript code is triggered. It's the same thing with the kernel. So you have a kernel event, I want to write a file, boom, I trigger a program. And eBPF at the end is this approach. So eBPF is that approach. So to be able to react on events, the best way of doing it is to rely on BPF. So all what we expect from those components is to have a daemon set, so one workload per node, with the BPF probes. So let's figure out. So starting with Falco. So Falco, you will see it has, as expected, a daemon set with the BPF. And then he has another workload, which is the actual Falco server. And then this is what we get when you deploy it. But at the end, what usually we have to use behind the scenes when you start to want to collect the data, you will have to use another project called Falco Psychic that will be aware, that we here, you will see later on the observability side, to simplify the observability experience, to collect data. Then the second thing is Tetragon. Tetragon, same thing, eBPF probe, that's the core of Tetragon. And then it has an actual operator, meaning that we have CRDs. So those CRD, we'll see, they will help us to configure our policies that we want to deploy. Then we have KubeArmor. So first KubeArmor, you can say, oh, why do we have so much things here? All right, so let's try to understand why. So first we have the daemon set, like explained, the BPF probes and the problems. We have the operator, so the, KubeAmor is an actual operator that has more CRDs than Tetragon. And then we have two workload. One is called the controller, and the other one is the relay server. Relay server has a role in the observability pieces, and controller, today I don't know what's the purpose of controller. So if someone has the answer to my question, what is the role of the controller, please let me know. I will be very interested about that. And then we have KubeScape. And then here you can say, wow, there's many things. Yeah, that's true, there's many things. There's a daemon set, again, eBPF probes, but then they have one workload for detecting network policies. They have one workload for scanning for your container runtime, so scanning your container for CVEs. They have a one container from yesterday, Constance explained with the bobs, the SBobs. It generates an application profile. Basically, it covers all the spectrum that you need for security. So that's why you have so many workload behind the scenes in KubeScape. And for that, they have tons of CRDs, because at the end you can configure, but you can get the results. Do I have some suspicious things? Do I have some CVEs? So every feature that I cover, will have a CRD providing the details about that. All right, so next stage is, I think I'm talking only to those guys today. All right, so capture and filter. Like I said, it's a camera. So we're putting a camera in our Kubernetes cluster, and we want to detect anything that could be wrong or could be suspicious. And then, like I said, I'm taking control on a container. I will try to basically touch the security account to figure out, oh, do I have, which rights do I have on the security cluster? So I will touch a file. I will probably, if I want to launch some processes, install extra tools on the container. So I will probably do some processing. I will probably change, if I can change privileges, anything like this. Basically, what a hacker could do on our cluster, on our containers. So we need to detect this. So detecting those things is important, but enriching the problem, not the problem, but enriching the event, because it's an event at the end, will be very important. So what are the process that is involved, the parent and the current process? What are the user details? Who is doing this? Kubernetes metadata, which files has been touched, and so on and so forth, and the system calls and so on. And then once we want to capture, if I'm a security expert, I know what I'm doing, so I can do my own rules, perfect. But sometimes, to be honest, we have a lot of people that are not security experts. So having predefined rules would be kind of a privilege, to be honest. So I can install the product, deploy the predefined rules, and then I know at least that the common security risks are covered, and I will be sleeping, be able to sleep on night without being worried about that. And then last piece is about to react. Detecting is great. Being able to block the actual event is even better. So let's figure out each tools one by one, starting with Falco. So first thing, Falco is not a security agent. Did you know that? Who was? No? Nobody knows that. Nobody's raised. So Falco is a rule-based engine. It's basically, the idea is that you have Falco. Up. Oh, okay, too fast. So you have Falco, and then up. Okay, never mind. Animation didn't work well. So you have Falco, you send a rule you send an event to Falco server, and server says, oh, does it respect one of my conditions? Yes, I'm going to throw events. So that's what the nature of Falco, and that's why there's many plugins out there for different sources. And one of the default plugins that comes with Falco is the kernel plugin. And the kernel plugin is the eBPF probe that will capture processes, files, whatever is running on Kubernetes. But you can also be creative. You can build your own. There's an SDK. You can basically code your own plugin. So, let's say I want to have something that collects emails and then send it to Falco. And then based on my emails, I can do some conditions. You have the freedom to do that. Falco is basically like not the OPA of the world, but OPA for runtime. So at the end, this kernel agent, as we expect, because this is how we're going to evaluate it, it's able to capture whatever we want, process, files, syscalls, and everything. And then it produces an event that is structured with a couple of details, so I have the host names, an output, and then the output field, it's basically unstructured. We'll see that why. There's a reason why it's unstructured. And then you have different tags that you can add, the rule, the source, and so on. So why is it unstructured? Why? Well, because they have a way of building their own rules. So they have their own language. So here's an example. And then you can see that there's output. And they have a language to say, oh, this is how I'm going to send my data to the output. So the structure, they really depends on who built that rule. So if you have an author 1, author Kevin is, let's say Kevin is creating a rule, and then you have Paul that creates a rule, probably the format is different. So the processing of the event will be obviously different based on the structure of that output. The one thing that's also different is that Falco, when it starts, it loads a rule file. So it has a huge file with all the rules. And then basically it goes there. So which means it's great because it's a one big file. I can use this notion of macro. So if I have the same condition about the process, the file, blah, 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 I can reuse it by calling a macro in my rule. So that's kind of smart. But the disadvantage of that global rule is huge. So before creating your own policy, you need to understand all the actual rules that are inside of this file. So that's, I would say, somehow is a bit of disadvantage from that design perspective. And then, of course, you have the field, so you can expose other data. Now, covering Tetragon. So Tetragon here, by nature, it's basically an eBPF probe that sends. And if you just install it, it doesn't provide. Oh, by the way, sorry. Falco has predefined rules. So when you deploy it, without doing anything, boom, you have all those presets of rules that is running behind the scenes. Tetragon, you deploy it, and you won't have predefined rules. The only thing that will capture when you install it is a process that started and the process that's ended. So it will be producing lots of events in your cluster. That's great. Very chatty. And then if you want to narrow down and filter to specific events or block things, you will have to create what we call policies. And that will basically be your own rules. So you'll have to build your own rules. And then the way the event is structured is insane. There's so much details. So you have the type of stuff. So here it's a process exec. But if you do a kprob or uprob, we'll touch base on later, it will be the root element of the event. And then you will have the process, the parent process, PID, UID, the binary there. It goes well. It's insane, the details, number of things that you can get. And the notion here of Tetragon is pretty much really deep into eBPF. So I don't know how much you know, but you can have a kprob, uprob. So kprob is a kernel function. Uprob is a user function, so user space, in the user space. And then you have trace points, so it's more on a kernel events. And then you have LSM. So when you do, this concept, then you will create a policy, a tracing policy. And here's an example of a kprob, you can see. And then you say, OK, I want to focus on a specific kernel syscall called TCP connect. And I know that all you in the room know exactly the C code of TCP connect. I mean, that is obvious. And I was the one also. I was surprised that I didn't know that. So I had to search for the arguments. Because at the end, it's so powerful that if you know a function, you say, OK, so please extract argument 0, index 0. See here? And I know that argument 0, come on, TCP connect. It's a socket. I knew that. And then, so then basically, if you want to extract things, so you will basically define what you have in terms of arguments, the detail that you want, and then you will, Tetragon will capture it and decode it to make to a text format so we can understand it. So that is amazing, but I don't know, I'm not as expert as you guys are. I had to search for each individual function. So that was a poor experience from my perspective. But once you discover it, then you say, wow, it's about infinite and beyond. And then once you have that, you can even play with the arguments. Oh, I want to index 0, and then you can build filter. Index 0 is a socket, so yeah, I can say, I want to basically grab a filter where the IP address is without those range. So you can do, it's just crazy, but you have to be someone that loves the kernel, that reads the kernel code before sleeping, and then you will be able to use Tetragon properly. Of course, you have tons of way of filtering, processing, and then even on the way you can react, it's insane. You can block, you can audit, you can send a custom code to the process, and then you can react based on the code. You can do so many things, it's just impressive. And that's, I think, the power of Tetragon is you don't have SDK, because by nature, you can do whatever you want. And that is impressive. KubeArmor. So KubeArmor here, it basically produces, once you deploy it, it only produces events if you have deployed policies. So there's no predefined policies. There's a repository of examples, but there's no policies defined. If you want to build your own policy, of course, similar to the other solutions, you will capture everything related to eBPF, process, network, Kubernetes, and so on. But if you want to be able to produce a policy, you need a structure. So you will ask KubeArmor to produce events. And that is great because with this operator, you can put annotations to your namespaces or deployments as, oh, I want to capture a file or a network or whatever, and then boom, it will produce events. And then once you have that, you will be able to design your actual policies. And then once you define the events that it produces, it is very, very, very structured. Always the same structure, so very, very simple to process when it comes to observability part. The policy structure here, you can see they have more CRDs. They have one for the cluster, so cluster policy, cluster-wide policy that could you apply, cluster armor policy for namespace or deployments. And then you can also trigger only one host, so the cluster host policies. I mean, at the end, the structure is the same. It's just it's targeting different environments. Do I really need 3 CRDs? Maybe 1 CRD could be enough. I don't know. I mean, that's why my impression when I started using it. And like I said, the way you define the actual event, once they have their own format, so you cannot randomly build it. You have to actually have an event produced by KubeArmor, and then once you have the event, then you can start designing your actual policy. And then in terms of the details, you can filter on many, many things. And one of the advantage, I would say, similar to Tetragon, that it's able to react, to block. And then what is great is that with the annotation, you can have a rule where you block, but for this particular namespace, you can put annotation, you authorize it. So you have different way of designing your policy, which is, I think, really interesting compared to the other solution that doesn't do that. Last is Kubescape. Kubescape comes with predefined rules. So no way of customizing. And it covers pretty much everything that we want. And the other thing that it do, compared to the others will produce tons of events. And then you will be realizing that, oh, a lot of things is happening on my system. Here, Kubescape has this notion that Constance explained yesterday with application profile. So when you deploy the app, basically it's understand your app, produce the app profile. So now there's going to be the SBOB, where it says, oh, my app needs that process, that Kubernetes, that files, that blah, blah, blah. So it lists everything. And then every whatever minutes, it rescans the app again and looks at the diffs. So, oh, there's a new process that suddenly appears on my container or my pod. This is abnormal. So then you raise the alerts. So I think that's really smart because it's completely different from the others where at the end you need to configure policies, you need to know the kernel, and here it's a bit simplifying the things, how it goes. So one of the components here, the eBPF stuff, that Kube is called node agents. That's the actual component that has all the eBPF logic. And the eBPF logic is not basically random eBPF code. It's basically inspector gadgets behind the scenes. So they rely on inspector gadgets. And then the way when you deploy it, it basically enables all the rules that comes with Kubescape. And then if you want to disable rules, you just edit the runtime alert binding, where you basically remove one of the rules that you have deployed by default. And then you can also customize. You can have, I'm going to have a different type of rule set for different namespace. You can also have like a control on what you want to apply or not. So for that, on that regard, I think most of the solution that we covered covers what we expect, so capturing, of course, filtering as well. The only one that has default policies is, like I mentioned, Falco and Kubescape. And then on the ability to react, it's only Tetragon and KubeArmor. And then the customization aspects that I mentioned, Falco has this SDK. Tetragon doesn't have SDK, like I discussed. But like I said, just by nature, you can do crazy things. So it doesn't need an SDK. You can pretty much customize everything. Oh, OK. One slide up. Okay. All right, now I need your help. Oh, now I'm talking to all your room. God, that's great. Awesome. So observability. So like I said, security is just an extension of observability. It captures, detects an event, something, throw an event. So we want to be able to grab that event and then parse it and then report it any way we want. The thing is, those events, depending on the tool, could be could have a lot of details. So having the options to basically define what we want in terms of details is very important. The other thing is also, once you have an event, you don't want to have one event per milliseconds because it's going to be just increasing your log files. Being able to throttle. Oh, I have an event. Don't send me 100 times the event. Send me once per 5 minutes, and then we will figure out. So I think that's very important. And then out of just the ability of producing events, having details about, oh, by the way, I'm healthy, I'm still running as a product, I think it's important. Because if I have a camera setting into the airport, but no camera is working, then what's the purpose of having cameras on the airport? So it's the same thing. So having the ability to figure out, oh, Falco is healthy, Tetragon is healthy, is super important from my perspective. All right, so starting with Falco. Falco, like I said, produces events. It doesn't produce events on the eBPF agent. It's a rule-based agent, so everything will happen at the Falco server. So you can collect from any log agents of the market, no problem. But like I said, the main problem is that every output is different, based on who built the output field. So then that's where you will use Falco Sidekick. That will pre-process the output for you and generate JSON output, so it's going to be easier to basically utilize that data. So, and then the other thing that Falco does, it has, of course, all the events is a log at the end, like I said, but out of that, it has an exporter, Prometheus exporter on the eBPF nodes, the kernel plugin, sorry, and then it has an actual eBPF Prometheus exporter on the Falco server. So at the end, you can figure out, oh, my kernel agents are running properly, that's fine, and then also my Falco server is running properly. Or if I define a rule, let's say, oh, I'm creative, I'm creating a rule, and I don't know how to define it, so my rule has been rejected, then Falco will say, hey, I have rules, but those rules are not working. So that, I think, it's important. So Falco for that, great job. Now cover Tetragon. So Tetragon, basically, it produces everything from the kernel agent, so we can collect the logs. But the logs is so big that most of the solution will crop the logs. So that's where you go to Tetragon, you change the configuration file, and then you start to basically define what type of the fields you're interested in. Because 40% of what is exported, you don't need it, actually, in the observability stack. So defining this is important. And then the second thing, you can also define the throttling. If I have an event, how often do I want to raise it again? And that is very important. So that is done properly with Tetragon. Then the other thing that it has is two Prometheus exporters. One on the actual eBPF agents to expose metrics about the events, how healthy goes, the queuing, everything that is basically based on the actual agent. And then the operator itself will expose data about the policies. How many policies are loaded, how many policies have been rejected, all the things like this. So for that, KubeArmor, I think, perfect. So KubeArmor now is interesting. So it doesn't produce events. So it produces events, we know that, but it doesn't produce on the kernel, on the eBPF probes. It's going to be the relay server. So you have to first, so in 2 releases before that, there was nothing produced. So you have to go to the relay server and say, please produce the events in std out. And that will make the event productions. Now, by default, they've changed it, so that's perfect. Now, once you do that, the relay server by default will expose the events. So that makes our life easier when it comes to collecting this stuff. So the way it works is that you're going to use the collector, go to the relay server, grab the logs, and do processing. But they had an amazing initiative, which unfortunately has not been maintained since a long time ago. So they have a Prometheus, they have an OpenTelemetry receiver that is not compatible with the new version of the collector. So if you want to use it, you have to recompile it and rebuild it and make it also align with the new version of the OpenTelemetry collector. So yeah, you have to be motivated. But the value of that is that it's going to connect directly to the agents and grab the JSON data directly out of the agents. So direct to the source, more easier to parse as well. So I think that was an amazing initiative. So I have already asked several times, please do it again, because here it's on version 0.96 of the collector, and today we are on version 135 of the collector. So we can see that a lot of releases is been not followed. And the other thing that KubeArmor is currently working on, which is not there yet, yeah, there's no metrics. We don't know if KubeArmor is healthy. We don't know if one of the policies we've deployed is actually being considered by KubeArmor. So, yeah, we're blind. So that's, I think, the biggest disadvantage of KubeArmor for now. But hopefully, this will be resolved soon in the next releases. Now we have KubeScape. And KubeScape is insane. KubeScape produces traces, metrics, logs in OpenTelemetry format. That is amazing. They have their predefined collector, but you can also ship the data to your own collectors. I would say the traces is very for maintainers than anything else. The metrics as well. So they have metrics on OpenTelemetry, but they have also metrics on Prometheus. So at the end, you're a bit lost. That's they are improving it as well. So at the end, from an end user perspective, the Prometheus exporter makes more sense for now. And probably in the future will be changed. And one thing which is amazing about KubeScape is that it produces CRD, and that CRD holds the entire things that he has detected, all the events out of the logs, or even if you have any vulnerability. So if you have a kubevuln running, and KubeScape is basically running scanning your container for CVEs, I can basically use in the OpenTelemetry collector a receiver called Kubernetes object receiver that will basically interact with the Kubernetes API, get the objects, and then we can get every details. So it's insane, and put some scoring, some risks. So from an observability perspective, KubeScape is, I think, by far the best out of those 3 products. So to summarize, so collecting the events, we can do it on each of those solutions, no problem. It's just that the way of doing it is completely slightly different. We can extend the observability easily because they produce events, so we can utilize those details. On having metrics on the rules and metrics on the actual operator or the health of the solution, everyone does it except KubeArmor for now. Now, okay, I didn't have to say it. I hope I have another chapter because I think you're following better. I see a few people sleeping here, but the other one is following. All right. So on the KPI, what did I want it to measure? I wanted to measure basically the latency that those probes or security cameras are introducing. Technically, if I'm just watching, I should not impact applications. That's a theory. But I wanted to figure out, is it really the case? So that was the first thing that I wanted to report. The second thing is I wanted to report the actual footprint. So how much resources I'm consuming on the cluster. That's one thing. And then the hidden thing. Do you know eBPF? Do you know kubelet? Kubelet is basically reporting your resource utilizations in your cluster, but kubelet is only using at the user space. And all those products, they are putting probes that sits in a kernel, the hidden space. So you can have your kubelet says, oh, everything is fine. But no, you're dead. Because the eBPF probe is eating all your CPU time and all your memory. So measuring the actual eBPF footprint is a must, because otherwise you don't understand really what happens. Because at the end we'll see most of the resources doesn't consume much, because they are not consuming on the user space. All right, so what are the things that I wanted to test? I wanted to basically have the similar things compared. So I have the Falco default rules, KubeScape, same thing. And then in the middle, I try to basically have the similar rules to cover the same spectrum with Tetragon and then with KubeArmor. So I tried my best, to be honest. And then to be able to measure that, how did I do this? As the performance engineer, I said, OK, I'm going to do a load test without anything, so no agent. Check the baseline. And then I install Falco, do the same test. And Falco has everything defined, so no problem. And then I did the same with Tetragon. So Tetragon, just with the default events, so process launch and process ended, and then deploy policies. And then do the same with KubeArmor. And KubeArmor, in fact, I have a sets of more tests. So because remember, you can turn on events or not. And you can turn on events on logs, files, networks. So I did just KubeArmor without anything. KubeArmor with policies, and KubeArmor with policies and events. And last, KubeScape, but KubeScape has the policies, so nothing changed. So let's have a look at the architecture. And there's a QR code. So if this weekend it's raining and you're bored at home, have a try. Take a cluster, deploy it, and you'll see that you will have a fun weekend. You will not regret it. You can even cancel your Netflix subscription. I can guarantee that. All right, so what do we have in that cluster? We have, of course, an ingress controller, so we want to expose the app. I intentionally picked several apps. So I have OpenTelemetry demo, the OpenTelemetry project demo. I have UnGuard, which is another open source security solution to exposing an unhealthy, from a security perspective, application. And then I deployed a Goat namespace that has a lot of bash, where I try to basically connect and do some suspicious things on containers. And then, of course, we have the solution deployed. And then I install Inspector Gadget, because you will see that how do I measure the footprint on eBPF? Ta-da! eBPF, Inspector Gadget. All right, and of course I have Dynatrace, because I don't have a Dynatrace shirt, but because I'm working for Dynatrace. So check it out. And now let's look at the results. Starting with the load. So I did constant load and load policy. So constant load is 30 minutes of load of 50 users on each application. And then I did a load test, which is every 30 minutes I'm adding 50 users. So I have about 200 users per app. And I'm just sharing here the constant load, because the load was not applying any differences in terms of results. So I'll focus on the constant load. So starting with on the response times. So you can see a lot of graphs, but the results is that Falco is adding about 3.80 seconds, Tetragon 3.37. But remember, Tetragon has no policies. It's just running events. Now, KubeArmor is adding 5 milliseconds, and KubeScape 13 milliseconds on top of the app. So it's not, by the way, it's not application power microservices. Remember, the OpenTelemetry demo has 12 microservices. So basically, I'm measuring at the front end. I'm sending transaction HTTP requests, and I make the difference with it. So basically, it's all the bounds of all the calls where you have this added. In terms of memory consumptions, and on the application perspective, so the Tetragon operator and so on, the one that is more expensive in both sides is KubeScape, because KubeScape, like I said, is not doing only runtime. It does vulnerability, it does networking, so that's why it's more heavier compared to the others in CPU. And what is surprising is Falco is consuming quite a lot of CPUs. Because remember, it's a rule-based engine. So what it's consuming is basically the rule things happening on the user space. And then if you look at the eBPF footprint, KubeScape has more probes, obviously, and the second one that is consuming the most is Tetragon. So it's this line is Tetragon, and KubeArmor after that. And then last, we have the memory. On the eBPF side, KubeScape again, and then it's Tetragon, and then Falco and KubeArmor. Again, KubeArmor actually is doing nothing. There's nothing deployed. That's basically the footprint. Now we do with policies. So what that is, does adding policies add something? So at the end here, Falco was the same. Tetragon, we can see that an increase of response times. KubeArmor has an increase, and KubeScape, it was the same, so no differences. So we work very close by to what KubeScape was reporting. And then on the memory side and CPU, it's about the same, except on the eBPF side, where Tetragon starts to consume way more than before. And same thing for the memory. It's still KubeScape that consume more, but then we can see that the consumptions on memory has increased on the current side. Now, if I start to enable events, and that's only for KubeArmor, because the other one doesn't do it, does it? So here's the test where I enabled everything. Everything on the OpenToDemo namespace, not the others. And you can see that I'm adding 36 milliseconds compared to 13 initially. And also, if I'm not wrong, on the resources side, KubeArmor on the CPU started to boom increase on the consumptions. On the memories, it's quite the same thing. So there's no. So at the end, on the performance side, I would say from a latency perspective, Falco is doing a pretty good job. Even if it's not the most modern product, I think it's doing a good job. Tetragon as well. On the CPU side, Falco is consuming most of the resources on the user space compared to the others. And on the eBPF side, I would say that Tetragon, KubeArmor, and KubeScape, but KubeScape, consider the fact that they're doing more things, they're consuming more stuff. So this is basically the different scoring that made decisions. I would say that first, if you do security, you can see that it impacts response times. It impacts your kernel. It impacts your nodes. So don't try to deploy hundreds of rules. Try to narrow down to the one that you need, because you will have consequences. And that's just because of eBPF. So eBPF is a wonderful technology, but you need to control it to avoid having incidents. If I need to define who is the best, it depends on your expertise. I would say that Tetragon is a beast, but if you look at the docs, every time I go to this, every time I go to Cilium websites, I always feel stupid. I don't know why. And then after a few hours of crying and reconsidering myself, I start to understand the docs. But otherwise, it's an amazing product. I think Tetragon is a beast. The other one that I love is KubeScape, because KubeScape does everything for you. You don't have to configure. You don't have to. They cover what you need. So that's why I think, from my end, I have a slight preferences for Tetragon and KubeArmor. I have all the content on each of those solutions on Is It Observable, so check it out. It's there. Consume the content. If you love the content, love it. If you hate the content, you can hate it, of course. So but please let me know. Because at the end, if you want to improve content, I need criticisms. I need bad remarks from all you guys. And that's how I can improve my content. So watch it, hate it, and send me some feedback. If you have any questions, I think maybe we have some questions sometime. So you have any questions? Gosh, did I kill you or? Everyone is silent. Gosh. No questions? Oh. Really? Yeah.
Is it on? Yeah, now. 2 questions, actually. Here I am, if you're looking. First one is, do you also have any experience with Falco Talon for enforcement with Falco? And the second question would be how to make sure that a Kubescape app profile is actually not containing any malicious behavior in the baseline already.
So, excellent questions. So first, as you understood, Talent as a way of React. But remember, KubeArmor and Tetragon sees React. So basically, you have almost instantaneous, you're blocking things. In the case of Falco, the kernel event sends an event to the Falco server, and then Falco server sends the events, and then Talent comes in. So basically, you have a time frame of a few milliseconds happening. So I know it's nothing, but if you do a very efficient script of hacking, in a few milliseconds, you can get data. So that's why I'm not a big fan on the way they react. That's my own personal feeling. But they have also the way of reacting with Talon, but that's how I think. And regarding Kubescape, they are basically, once you deploy it, a few seconds after the pod has started, they start scanning it. So it means that if someone is already entering suspicious things in your processes, maybe your container isn't healthy. Or your cluster isn't healthy. That's my conclusion. But yeah, because once it's been running, then they start to scan your actual application profile. So technically, in the first seconds, if you already have some weird processes, then your node is being hacked, I think. Any other questions?
Yeah, thank you for the great talk. I have a question regarding more or less, it's more of a general question. I think a lot of these tools today are still using k-probes, but in more newer kernel versions, like from 5.7 on, LSM hooks are available. Have you ever run any performance tests whether LSM hooks will, let's say, cause less latency, cause less CPU? Like, what's your opinion on that?
It's an excellent question. Honestly, I never considered that test, to be honest, because in this particular case, I was doing those tests on Amazon, EKS, so I had the latest kernels. So I was more thinking, if I'm a user using cloud providers, I'm going to probably have the latest kernel available. So I didn't consider, but that's an excellent points. Maybe having an older kernel could have an impact as well. That's a good point. And yeah, the other question was, I don't remember. You had a question? No?